Hello everyone, this is Nilesh Gule. Welcomes you to the class of Asynchronous I/O in .NET. In the previous class, we talked about the file I/O and serialization. All the functions we used in the file I/O were synchronous function, meaning by the time operating system is doing file read or write operation, the current thread is blocked. And this is considered as inefficient approach in the modern programming. In .NET Framework 4.5, Microsoft .NET introduced Async await, and now it is highly recommended that if you are going for any kind of I/O operation like file I/O, network I/O, or database operations, you should always look for asynchronous programming. In this particular class, we will talk about the fundamentals of async programming. We will have few examples of async file I/O. We will also talk about how to get the data from internet using asynchronous I/O. So let us begin with the first asynchronous function. If we are trying to perform any operation which will take more time, especially due to the I/O operation, then such method can be declared using async keyword. And this async keyword will ensure that if the task, if the I/O is taking some time, then the current thread of execution is not blocked. In fact, it releases the current thread of execution back to the thread pool so that it can be used for some other task by the time current I/O is going on. If we are declaring any function as async function, then return type of the function must be task or task of t type. Here we are looking for one very basic level example where we are not doing the actual I/O, but we are simulating that I/O delay using a function task.delay. Let me show you practically how exactly we can write such functions and consume them. For that, I have already created one console application. And inside the console application, let me create my async function. So public static async task, and I call this as async task 1. In this particular function, I want to write a simple console.writeLine message. And then I want to simulate the I/O delay using the await task.delay. We will discuss about this await in more detail. And then let me write another console.writeLine where I'm saying task 1 is completed. Please note that this is very basic level example where this particular function is not producing any kind of result. And that's why the return type is only task. How you will be able to call this function? There are other ways of calling it, but at the beginner level, I want to show you that we will call it like this, where we will call the method and collect the returned task object. And then I want my main thread of execution to technically wait for that execution. Now let me write some console.writeLine which is showing main thread is started, and at the end I want to also write the message main thread is completed. Let us run the application and check what is happening. When I run this application, you can see that first main thread started. It has given call to the async task 1, which print task 1 started. But after that, you must have noted that the task1.delay is called, which is a synchronous operation, maybe taking 1 second, and it is writing await. Now, because of this, this particular async task 1 function is temporarily paused. At the same time, inside main, you can check that we are writing task.wait. Now, because of that, even your main thread is not proceeding to the next statement. After 1 second of delay, .NET enables other thread to execute this particular function. And when this function is executed, it will complete the task and then it will return. When control return back, the main thread continues the execution after task.wait and it will print main thread is completed. That was the result we were able to observe. Now let us try to return some result from the function. For that, I will comment this code and let me rewrite with another async task, which is providing some result. Let me call it as async task 2. And in this async task 2, I want to return any object. For sake of simplicity, let me consider a string where I'm saying that it is task2 result. Since this particular function is returning string, the return type must be task of string. And then inside main, we should be calling that particular function. Here again, we can first wait and then collect the result. But this task object has got interesting property called as a result property. This result property will internally wait for completion of the task and then collect the return value of that task. Let me try to print the result. Let's say task2 result is, and I'm printing this task.result. By the way, to get that result, we need to ensure that the return type is task of string. Then we can use this result property. Let me run this and you see again it waited for 1 second and afterwards the result is returned and that result is collected and printed in the main. After the result is printed in main, then main thread also terminated. This is how my simple async task is executed. Let us take a little time and try to understand how this async executed, and then we will also talk about some important points from this task object. To explain in short, whenever this asynchronous method awaits, the executing thread is returned back to the thread pool and task scheduler may use that thread for some other task. After completion of this delay, after completion of this IO, a thread from the thread pool is assigned to complete this particular task. The primary advantage of this async function is it doesn't block your main thread. So your UI application doesn't freeze. If you are using it in context of web applications, in that case, the web server can handle more number of requests because if any of this particular thread is performing asynchronous IO, it will return back to the thread pool and web server may use it again for handling some other request. This gives the better scalability, especially for the IO bound operation. Something very important to note and understand, asynchronous operations does really good for the IO bound operations. If you want to do heavy CPU level tasks, then async is not good choice. Rather, you should go for parallel programming. But the question is, when I'm writing async function, what is happening behind the scene and how exactly this thread management is done? You'll find that whenever we are writing async method, internally C# compiler will generate a state machine logic, state machine kind of IL code for that. And it is encapsulated inside one hidden class. You can see that class if you open your assembly into IL diagram. This hidden class has got two very important members. The first member is state field. When the function is called for first time, at that time, the state is marked as kind of -1, saying that the method is started. But as this particular method progresses and when the await is called, due to await, it will preserve its current state. It can be seen like a bookmark. We put it in the book. If we want to stop for some time, then this particular state is saved behind the scene, and afterwards, when the task is completed and method is to be resumed, the .NET assigns a thread from the thread pool. It will internally call the next member moveNext. This moveNext member will actually check where the method was stopped last time, and from there it will continue the execution. This is exactly the way how the async method is executed internally. Note that the thread that is assigned after waiting to resume that, it may not be the earlier thread. It can be some other new thread from the thread pool. We can verify this in our example. So let me go back, and in this example, I also want to print the thread ID beside this. So to print the thread ID, we can use the thread class, and we can say thread.current thread plus the thread ID. We will print this thread ID again after resume. And for your information, let me also print thread ID into main. Now let me run this, and you can note the actual IDs of the thread. Here we will find that when we begin the execution, let's say that main thread is started, the ID of the main thread is 2. Then we are calling async task2 function. This async task2 function is begun using the same main thread. That's why ID is 2. After that, it waiting for 1000 millisecond. When it is waiting for 1000 millisecond, immediately the control returns back to the main. When control return back to the main thread is calling task.result. And due to that, main thread is paused. Here, this particular task is waiting for 1000 millisecond, and then the task scheduler will assign some thread for execution of the remaining function. Please note that over here, this particular function thread might be different. Here we can see that the assigned thread is thread ID 10. This will complete the execution and produce the result. Main thread who was waiting for the result will collect the result, and then it will print it. You can check that the main thread is completed with the same ID 2. This is how internally asynchronous tasks are executed. Let me take you back and understand quickly about this task object. As I said, this particular task object is return type of asynchronous task. It is representing the operation in progress whose result may be available later if the function is not void. And we talked about two most important members of this task. One was wait method, another is result property. In both of them, calling thread will be blocked. Of course, this is a blocking operation, and this is not considered to be efficient. In fact, it may even cause the deadlock. It may freeze the UI of the application. So whenever you are calling asynchronous functions, the appropriate way is to use the await keyword. Let us understand the await keyword over here. Typically what we can do is we can collect the task object, and then we can use this await keyword. But for that, you need to understand certain things. Note that await keyword must be called inside the async method. This await keyword is responsible for pausing the method execution and releasing the current thread back to the thread pool. This await keyword will always work with the object of task or task T, which is typically written by async functions. Though we can write the code in two steps, where we first collect it as a task object and then wait for that, more readable and commonly seen pattern is directly use await with asynchronous function, where asynchronous function is returning a task object and we are waiting for that task object. After the task object is completed, then it will return the result. We can understand it with one example. A simple example of the pizza order system. You consider that you are ordering pizza at the counter. This is asynchronous work because there will be someone making pizza for you. Now, by that time, what you will do? Over there, the person on counter will give you some token number, and which ensures that you will get your pizza in some time. What exactly you do at that time? Instead of just standing over the counter, you may take some time and scroll through your mobile. So you are utilizing your time for doing some other operation. Moment you get a call that your token, your pizza is ready, then you resume and you collect that particular pizza. This is a simple example which will help you to map async, task, and await. I hope you got the basic concept. Let me quickly call the await over here. Instead of calling it like task.result or task.wait, let me call it using the await. Let me do it into another main. In this main, we are now preferring to use await keyword. And this await keyword will directly return me the result that I'm looking for. This result we can print later or do further processing. But as I said, it is mandatory that await keyword must be used inside asynchronous functions. And .NET also allows you to have asynchronous entry point main. So I can mention it as async and return type can be modified to task. Now you'll see that this will work in exactly same way as of earlier main. However, this is most recommended way of using async and await. You've seen that it produces exactly same result. Please note that mixing up async await with this kind of blocking method like wait or result is considered to be really bad idea. You should follow async programming all the way, right from the beginning till end of the flow. Now that you understood the basic syntax of async and await, now we can write the programs for the file IO once again. So going back to the file IO concept. So we already talked about the file IO and we used all file IO functions in the synchronous manner. However, as I said, due to that, your UI may be frozen. And that is the reason asynchronous file IO is recommended. It is very common convention that if any method is asynchronous method, it is suffixed with async word. So you'll find that there are so many different methods. You'll find it into the file class or StreamReader, StreamWriter class or FileStream class, which have the suffix async. The method like read all text async or write all text async. For that sake, StreamReader dot read to end async. Similar way, we have FileStream dot read or write async. All these async methods are returning the task object. If you want to use any of these methods, let me have a quick example. As you can see, in this particular program, we already have one file. This particular file, let me get the path and let me try to print the whole file. How we can do that? For that, I'll write another main and we will try to write the code in that. So I will write public static async task, and inside this I want to read the file, and for this file we have given display path. Now to read that file, earlier we had used the helper class method file dot read all text, but this read all text is a synchronous method blocking the current thread. Instead of that, I should prefer read all text async. You can see that the return type of this method is task of string. So we can call this method, pass the path, and we can use the await. This await will actually return me the result of this method, which I can collect it as a string text. And then we can directly print that text. Let us run this and you will see that the whole file is printed. This is very easy way we can execute the code asynchronously. On similar lines, you can also go for other methods like read all lines or write all text async. These kind of options are available. Going ahead, if I'm not willing to use this particular file helper class, can I use the StreamReader or StreamWriter class? Yes, even StreamReader and StreamWriter also have option to deal with these IO asynchronously. Let us give a try. Again, I'm creating another main. And in this main, we are writing the similar code once again. Let me again take the same path. And then we will use the using block to create the object of StreamReader. And this StreamReader is having a method reader.read to end async. Again, this method returns a task for which we are waiting and then collecting the result. Now we can print that text. You can run this and you can cross check. Again, you are getting exactly same output. Let us go ahead. I guess I told you even the stream reader is internally using something called as a file stream and then getting the data from the file stream. So to understand this better, let me go at the lower level to get the more control, and we will try to directly use the file stream. For that, let me create another main, and in this main, I want to use the file stream. So let me use file stream over here. When I'm using file stream over here, I need to be careful about its parameters. In these parameters, we need to pass, let's say, file access read. The another thing we want to write is file share read so that the other applications can read the file. Apart from that, we want to give some buffer size, that how much data it will be able to read into the memory. Let's say the standard buffer size people keep is 4096. And then very interestingly, the last parameter. The last parameter is use async, which is by default false. Since I want to do asynchronous programming, I recommend this that you should put it true. And then we can use the asynchronous method to read or write in the stream. Of course, currently I'm opening it only for read. So let me show you the demo for read only. Here we can declare some buffer. It is your choice that you want to declare buffer of what size, because it is going to be the local buffer in which you are reading some bytes. Please note, earlier This 4096 is the buffer used by the .NET internally to get the data from the operating system. Over here, we are declaring our own buffer to collect the data into our application. You may keep it 4096, or if you want, you may keep it even less. Then we will use stream dot, let's say, read method. But this read method is going to be synchronous. We want a asynchronous version of that, where I will mention that read the data into the buffer starting from the beginning of that buffer, 0th index, and maximum we can have length, these many bytes. What this read async method returns, please note that it collects the data into the buffer, but it returns the task of integer. So actual result is going to be the integer which represents the number of bytes actually read. So you can collect that particular data using await, and then you can print that. But to print that, currently I need to convert this byte array into the string. Currently this is giving me error because I need to import this encoding, where I can simply say system.text, and then this particular text we can try to display. Please note that using FileStream, we can get the more control over the stream manipulation. We can perform the write operation, read operation, and so on. Currently, since the buffer is only of 1024, it has read the data partially, not the full file. If you want to read the whole data, you might put this block code into the loop. Something very important that I should be telling you, that ideally, if you are doing the file IO or network IO, you should never leave your code like this. You must think of using the try-catch block. Exception handling is absolutely required because there can be n number of errors you may see during file IO. Right now, if at all there is an error, let me print the error message over here. We can run this and we can see the current output. Let me take you back where we were talking about this basic example of how we can read from the file, and we can use the helper method for writing to the file. As I shown you, we will use the file stream for reading the text, where we have given use async last parameter true, and then we are reading the data. Important points to understand when we are doing asynchronous file IO. First, always use await for asynchronous method. Never use .result or .wait because it will block the calling thread. Asynchronous file IO will increase the scalability, but it never increase the actual speed, because actual speed of the file IO depends on the actual hardware and operating system. This is really useful when you want to deal with huge file, or you want to perform multiple concurrent operation, or you want to do such kind of IO inside your web server or UI application. For very small file to read, or you want to read some sort of a configuration file at the beginning of the application, this may not be required. In this particular case, whenever we are doing IO, internally, the actual IO is performed by the operating system. When we are waiting using that await keyword, the current thread is returned back to the thread pool. And once the IO is done by the operating system and given data to the .NET, then some thread is allocated to execute the async operation further. This is how the file IO is getting executed behind the scene. We already discussed about file IO in the previous class and given you the idea how you can perform the asynchronous file IO. I leave it to you to explore the remaining methods in asynchronous file IO. Now it's time to talk about the HTTP client. The primary purpose of the HTTP client is to send HTTP request and get the HTTP response from some web server. This is very commonly used for calling the web APIs. If you do not know about HTTP protocol, I first recommend that you can refer the video in the link to understand the HTTP protocol and its basic method like get, post, put, and delete. And then you can continue on this discussion. Assuming that you are aware of the HTTP protocol, in this particular demo, I will show you how we can collect the data from internet, from some web server into our application. Here, I will prefer the JSON data. In future, as you will be working on REST API, you will be producing lot of JSON data, and also while calling the REST APIs, you will be consuming the JSON data. So purposefully, I want to take exactly similar example. You'll find that this HTTP client has got certain methods, and these methods are get async, post async, or get string as async, get from JSON async, and then there are other methods as well. You will realize that all these methods, they are designed to be used with await keyword. These are all asynchronous operations. So how we can give a try? Let me show you the data. Suppose that I have this sample data. This sample data is novels.json, and this novels.json is giving information about some Marathi novels as JSON array. How we can make asynchronous call using HTTP client? Let us give a try. Let us go back to the Visual Studio, and in this Visual Studio, let me write a new main. Let me declare the URL over here. Now, from this URL, I want to get the data. For that, I will first create the object of HTTP client. We already seen few methods of the HTTP client. So let us try some of the method. You may see a method called as a get async. We can pass the URL and it will return me certain object. You will note that this particular object is basically the response. Typically, it is HTTP response message. And then from that response, I may check the status manually. From that response, I may get the body manually. But there is easier approach. Instead of getting the response and manually checking it, I will call get string as response. Considering the response body is having the textual data, let me take all the data as a string. And once we have that all data as text, we can directly print it in our application. So let us try to run this, and you will see that the data which was available there is pulled over here as a string, as a JSON, and shown it to you. But you may not be interested in just getting a data and printing it. This particular JSON data, I want to collect it in some objects and I want to use it for further processing. How we can do that? I hope you remember we talked about something called as a JSON serialization and deserialization. As our data is already JSON data, we can simply call JSON serializer and we can deserialize that data. For that, we need to first write a class. Let us write a class novel. And in this novel class, let's say I can have a title, I can have an author, I can have a category, and then I want to also have some price. Apart from that, I need some ID. If I have put all these members, then I can use it for deserialization. Let me quickly also add one toString method. Now we will use JSON serializer for doing the deserialization. Let me use JSON serializer dot deserialize. And while deserializing, I want to deserialize it into novel array. You noted that whatever was returned, it was an array of novel data. So let me deserialize at novel array. And this will return me the array, let's say novels. And then I can simply use a for each loop and we can try to display it. Let us check if this is working well. Unfortunately, you will see that when I try to call display method, it may not give me the expected result. You see that ID, title, author, nothing is matching. And the primary reason is the data we have all the fields in the small case letter and the field names are different at some place. While over here, everything is in capital. How do we handle this? I'm sure in last lecture, we also talked about something called as a JSON property name. So let me give the appropriate property name. Let's say serial number. Let me put it in a small case title, then small case author, then small case category, and finally the price. Let me run the same application once again. And now you see that the data that we were looking for is available properly. By the way, over here, we executed the things in two steps. First step, we perform a synchronous operation and collected the data as string. Then that JSON string we pass to the deserialize method, then convert it into the array of novels and then printing it. So the parsing and data fetching were done as two different operations. However, we can go one step ahead and we can combine this together. Let me show you. Let us create another main. And in this main, I want to write similar logic once again. Once again, I will use the URL. I will create the HTTP client and then I will call the method client.get from JSON async. Here we are trying to get the data and also deserialize it in the asynchronous operation. This will return me the novels. Let's say where novels, and finally I can print it. Let me run this and you should be able to see exactly same result. In this particular case, I want to make it very clear that if you are dealing with this sort of operations, you should always do appropriate exception handling. Because in this particular case, I haven't done any exception handling, while there can be n number of possible exceptions. There can be network failure, there might be URL is not available, there might be some issue on the server side. So let me put this block code into the try catch block. If at all I'm getting any exception, let me print the message and then exit. Another important thing to note, since we are using HTTP client over here, this client internally holds many resources and it is one of the heavy object. If you want to use HTTP client in the real application, it is good idea to create a single object of HTTP client and reuse it for multiple requests. Also, it is very important that after you finish its use, you should release the resources. And best way of doing that is dispose method. So I'm using the using block so that my resources are closed. Let me take you back to these concepts. where we talked about the HTTP client used to get the data from the internet, which is internally sending the GET request, collecting the JSON data, and then either we deserialize it or we combine it together, getting data as well as deserializing. How exactly things executed? Please note that the request was sent over the network. Then, due to await operation, the thread is released while waiting the response from the server. Once response is received, another thread is assigned, and that thread will actually perform the deserialization, return me the novel objects. This makes my code more scalable. The thread which was waiting can perform some other operation meanwhile. As I said, you should never skip exception handling. There can be any number of reasons why it may fail. And I already told you, HTTP client must be reused. It is very bad idea to create a new HTTP client for every new request. In this particular session, we talked about the modern asynchronous IO pattern in .NET. And it is highly recommended that all kind of IO must be performed in asynchronous manner. We learn about async keyword, await keyword. We talked about the task object. Then we also seen couple of methods how file IO can be done asynchronously. And then I shown you how we can use HTTP client to get the JSON data and deserialize it into objects of our class. I hope you find this very useful. Thank you very much for attending the class. See you in the next session. Bye-bye.